Okay, today we're going to talk about trig functions. So you see this diagram on your notes. It says the radius vector r is the distance from the origin to a point on the terminal side of theta. Since r represents a distance, it is always positive. Go ahead and underline that. It is always positive. You're going to have to remember that. Even if I have an angle that starts here and goes all the way over here, okay, even if I have a vector going this way, my r is still positive. Okay, so it doesn't matter what quadrant it's in, that vector is always positive. All right, so let's go ahead and talk about trig functions. On your notes it says for a given value of theta, the ratios of y over r, x over r, and y over x are constant because of similar triangles, thereby satisfying the requirement of a function that for each x value, or in this case theta, there's only one y value. Okay, so let's talk about the trig functions that it shows on your notes. What they did is from this vector, they went ahead and made a triangle out of it. Okay, so you have this distance x on the x-axis, and then this up and down measurement would be y, right? So that's on the right side of your notes at the bottom. There are 6 different trig functions, okay? One of them is sine, and sine is going to be y over r. Okay, cosine is going to be x over r. Tangent is y over x. And then, and I like how it has it written in columns like that, because cosecant, this one is cosecant. It's the reciprocal of sine. So cosecant is like saying 1 over sine. Okay, so what we're going to do is take our sine, which is y over r, and just flip it. So it's r over y. Secant is the reciprocal of cosine. So 1 over cosine, you're going to flip your cosine, so it's r over x. Cotangent is the reciprocal of tangent, so we're going to flip our tangent to be x over y. Okay, I'm almost positive y'all are going to have to know this. There is a trick to remembering this, and I learned it back when I was in high school, and I still use it. And the trick to remembering it is SOHCAHTOA. Sounds like a tribal name or something. SOHCAHTOA. I always think of Pocahontas whenever I think of SOHCAHTOA. So let me tell you what it stands for. And it makes it a lot easier than just memorizing X, R's, and Y's and stuff like that. So the S is for sine. O is for opposite. And H is for hypotenuse. Okay, so if I'm trying to find the sine, I'm going to do the opposite over the hypotenuse. So y over r. So that's the SOH. S-O-H. The next one is cosine. So if I'm finding cosine, I'm going to do adjacent over the hypotenuse. Okay, adjacent, whenever I say adjacent, it's the side adjacent to the angle. Same thing with opposite. Whenever I say opposite, I'm talking about the opposite side from the angle, the one that's opposite of that angle. Okay, so for cosine, I'm going to do adjacent. In this case, my adjacent side would be x over hypotenuse. Okay, so x over r. And then the last one, TOA, is tangent Tangent is going to be the opposite over adjacent. So my tangent is going to be y over x. SOHCAHTOA. So I would definitely write that down. I really don't know a math teacher that doesn't use SOHCAHTOA. So everybody uses it because it helps out a lot. All right, so now we're going to work some problems that uses this SOHCAHTOA, the sine, cosine, tangent. The reason we don't have the cosecant, secant, cotangent in our little trick is because you're just going to flip the sine for cosecant. You're going to flip the cosine for secant, cotangent, stuff like that. So if you can remember SOHCAHTOA, you can figure out the other three. All right, so turn to the back. What they give you is a point, and they want you to find all 6 trig functions from that point. So let's start with the first one. We have the point is 6, 8, right? Yeah. Okay, so what I do is I go ahead and draw that triangle. So if I have the point 6, 8, that's telling me my x and y value, right? My x is 6 and my y is 8. So my x is positive. I'm going to go over 6, and my y is positive. So it's going to be a positive 8, like that. And that'll get me to that point 6, 8. Okay. And then I can make a triangle from there, and I have my vector. So I have theta, I have my x, and I have my y. Now to figure out what my r is, with triangles, we use Pythagorean theorem. A squared plus b squared equals c squared, right? So a and b are my sides. I'm going to do 6 squared plus 8 squared to get my hypotenuse. Okay, so what is 6 squared plus 8 squared? 100? Yeah. So 100 equals c squared. If I want to find c, I'm going to take the square root of that, and I get plus or minus 10. Now, like we said before, my vector, my r, is always positive. So it's just going to be a positive 10. You don't have to worry about the negative 10. Okay? All right. So now we're going to find all 6 trig functions. Let's start with sine. So sine theta. If you remember SOHCAHTOA. Okay, my sine is going to be the opposite over the hypotenuse. So opposite of this angle would be 8 over my hypotenuse, which is 10. Okay, 8/10. And I want you to go ahead and reduce your fractions. So this would be 4/5 for sine. Okay, cosine. Remember your SOHCAHTOA, cosine is adjacent over hypotenuse. So the side adjacent to that angle would be 6 over my hypotenuse, which is 10. Okay, reduce that fraction, and I get 3/5. Okay, tangent. Tangent is going to be opposite over adjacent, so 8 over 6. Reduce your fraction, and you get 4/3. Okay, so that's SOHCAHTOA. Now we still need to figure out what cosecant is, what secant is, and cotangent. So what I do is I take my answer from sine and I just flip it. So cosecant would be 5 over 4. Okay, I just flip it. Secant would be 5 over 3 if we flip it. Cotangent would be 3 over 4. Okay, so that's how you find all 6 trig functions. All right, so the next few examples are some from each quadrant, so we'll be able to go over one of each type of example you'll see. Okay. All right, on number 2, you have the point -5, 12. So my x is negative. So on my axis, I'm going to go to the left, to the negative side. My y is positive. So from there, I'm going to go up 12. And that'll get me to that point -5, 12. Okay, let's go ahead and make a triangle out of that. So I have my angle, I have my vector. Okay. All right, so we need to figure out what the hypotenuse is. So we're going to use Pythagorean theorem. A squared plus b squared equals c squared. We have our two sides. So we're going to do -5 squared plus 12 squared. Make sure if you put this in your calculator, you put parentheses around -5, or else it's not going to be right. Okay, so -5 squared plus 12 squared gives you 169. Okay, the square root of 169 gives me plus or minus 13 for my hypotenuse. Okay, and your vector is always positive, so we aren't going to worry about that -13. There will be a point where you are going to take the negative of that square root, but I think that doesn't come around until next week. It might be this week, but so don't just always take the positive. You're going to have to think if you need the positive or the negative. But for the hypotenuse, you always want the positive. So we have our third side. Now we can do sine, cosine, and tangent. So our sine is going to be, and I would, at the top of your paper, at the top of your worksheet today, go ahead and write out that SOHCAHTOA so you have it to look at. Okay, so sine is going to be opposite over hypotenuse. So the side opposite of this angle would be 12 over my hypotenuse, which is 13. Okay, and that doesn't reduce. Cosine is going to be adjacent over hypotenuse. So my adjacent side is -5 and my hypotenuse is 13. Okay, tangent is going to be the opposite over adjacent. So opposite would be the 12 is the opposite of that angle. So 12 over -5. Hope y'all can see that. That's a 12. 12 over -5. All right, so now we're going to find our other three. So cosecant. For cosecant, I'm going to flip my sign. So flip it. It's going to be 13 over 12. We're just going to do the reciprocal. Secant, I'm going to flip my cosine. So if I flip it, I get -13 over 5. It doesn't matter where that negative is. If you want to keep it with the 5 at the bottom, you can. If you just want to write a negative out in front, you can do that too. It doesn't matter. Cotangent, I'm going to flip my tangent. So if I flip it, I get -5 over 12. Okay. So that would be my 6 trig functions for number 2.